So quiz last time. And we're still waiting on some people to finish it. But if you are unhappy with the grade that you wind up getting on it, you can definitely do quiz corrections. The way that I made the quiz was I tried to make it so that you couldn't just Google every question, because I know that some people just do that. So if you didn't do well because you couldn't just look every question up, that might have been why. Oops, why did I make the waiting room enabled? But you know, maybe you just had a bad day or something. It was open notes, so if you took your time with it, my hope was that it should have gone pretty well. Let's see, who do we have? Let's see, Dennis is here, Manish is here. Somehow still wearing a winter jacket in all this. Dominic, no. Oh, more people are getting here. Let's see, Kara, no. Jalen. Oh, Jalen, you're not allowed to sit on that side of the desk. I'm sorry. You are allowed to sit two to a desk, but you have to sit facing this way. It's just the silly rules. I mean, sorry, the safety rules. That's what I meant to say. Liam's here, Savannah's here, Cheyenne is here. Yeah, it's kind of painful. Bianca is no. Winner's here, Taylor's here. Wes is here. Emily and Emily. Maya is here. Chico's here. Aaron's here. No, Aaron's not here. Lucas, Sophie, and Jaden. No Jaden. No Olivia. Wendy and Selena are here, and Vanessa is here. Okay, cool. So if I'm looking at my list, it looks like out of people that are here, let me see. Looks like everybody here. Oop, Jaden, I just marked you absent by accident. Here. And Jaden, looks like you started the quiz, but you didn't submit it. So I won't be able to score yours until you submit it. All right, so I know I have to go through and manually edit a couple of things. And I don't remember what happened to not have it done for you guys right now. But today we're going back to Savas. Trying things a little bit differently, but like I don't have a video lesson today. I am doing something a little bit more straightforward. So if you join me in Savas, side note, if you're at home, if you can crank your AC for me, I'm really warm. And so like, if you get to have a nice cooler day than me, I'll be happy. No, don't adjust your thermostat if your parents aren't okay with it. Also, I was talking with the teacher last block, and they were talking about how unappreciated they feel. And it just made me think, I'm not asking you guys to be nice to me. Don't give me compliments. I'm not asking for me. I'm saying if there's a teacher you have that like every day you have their class, or most of the time when you have their class, it like makes your day, or like it brightens it a little bit, send them an email or let them know, like say, hey, I really appreciate everything that you're doing. I really love your class, something like that. You'd be surprised how down teachers can get. Personally, I'm not doing too bad. I'm so tired from my kid at home that I, like the whole COVID thing has kind of gone over my head because I've been so getting used to being a parent. But I know a lot of teachers, if you've had a rough year with COVID, a lot of teachers have had a rough year too. So just think about doing that. You know, I actually I got an email from somebody last week and it made my day. You know, it's a little something that don't send it if you don't mean it, but if you mean it, it can be a really special thing. So anyway, I like this lesson for a few reasons. And the first is we get to start with an activity. And I actually have 2 activities. So we're going to start with the one actually in Savas, and then we're going to do a slightly different activity that we're just going to talk about something. So yeah, I made what they call it a playlist, but I don't know why they call it a playlist because you don't click play on anything. Let's see. Oh, I did share my screen. Okay. Oh, Sophie, I'm so jealous. All right. So yeah, if you go in, you'll see 6-2 notes in order. So you'll need a calculator, and you can use your Chromebook calculator today, like the TI calculator thing. I would use that. We can also use Desmos today, and whatever other calculators we want to use, but I want to make sure that some of the stuff we do, that we've seen it in Desmos. I mean, not Desmos, seen it in our graphing calculators, because those are the ones that you're allowed to use like on the SATs and stuff like that. So that's one reason why we emphasize them. Oh, let me hit the lights so it's more visible. Don't worry, I'm still not moving into like giving you guys real like homework assignments and stuff. We're still gonna have like whatever we get done in class for the day, that's our class for the day. That's gonna be the way that we do it. So yeah, have your graphing calculator ready and join me in our playlist. So the way that it should work, and let me know if I'm wrong, I've never used a playlist before. It should start with 6-2 explore and reason. Is that what it starts with for you guys too? Okay, great. So before we do that, this will give everyone a chance to get started. All right, so here's the thing. We're going to do a fake scenario. This is not real, okay? This is pretend. I am going to give you a penny today. Tomorrow, I will give you 2. The next day, I will double it to 4. We'll keep doubling it every day for a whole month. Or I will give you 100. So which deal do you go with? I'm going to give you a penny today. Tomorrow I'll give you 2. The next day I'll give you 4, 8, 16. Keep doubling every day for a whole month, 31 days. or give you $100 right now. I want to hear what you think. Just gut reactions. What do you guys think? Feel free to private message me in chat or group message in chat. Emily, what do you think? Say. Right. Yep. Just doubling just for 1 month. So just 31 days. So I'm just going to double it 31 times. Didn't realize I didn't have that shared with you guys. Sorry. There it is. So, Manish, what do you think?
So it goes from like 2 to 4 to 8 to 16.
Just, yep. And then just for that whole month, each day you get twice what you got the previous day. And you get to keep the penny from the first day and the 2 cents from the second day. So honest, like what are your first impressions? What are you guys thinking? No wrong answer. Nothing. Okay. So people in class don't think anything. People at home don't think anything. No one thinks anything. You guys are all liars. You have to think something. You want to go with the, why are you going with the penny? So you think it's gonna be more money? Okay. More money than $100.
Well, eventually you'll get to $100 if it doubles every single day.
Only for a month
So
though.
I feel like even though it's only for a month, it's still a lot.
Okay. Manish, what do you think?
I go with the second one. Like just a penny, like 60 cents is like worth $1. So it's not going to get you lunch for 31 days.
Do you think it's gonna double fast enough to get us there? Okay. Anybody like, this is probably a trick question. I was waiting for somebody to say that, and I was like, okay. Any other thoughts? Any other? So hey, check it out. A penny's this, right? 0.01. So that's the first day. The second day, we're going to add two pennies. So second day, I've got 3 cents. I don't know. It's sounding pretty good. I'm going to cheat and use a spreadsheet. Because a spreadsheet can do this really quick for us. All right, check it out. So here's 31 days, right? This is what we're going to have. So this is our time frame. .01. So I could just say I take that previous day times 2, right? So then the next day, do that times 2, we're gonna get 4 cents. The next day, we're gonna get 8 cents. The next day, we're gonna get 16 cents, 32 cents, 7 cents, 8 cents. I mean, 8 days, sorry. 8 days, we're at $1. I don't know. Here's 9 days, 10 days, 11 days. Oh, at day 11, you got $10. We're a third of the way there. I don't know. This might get us more money. 12 days, 13 days, 14 days, 15 days. Wait a minute. 15 days, halfway through the month, we already have more than $100. We got half the month to go. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. By day 25, we're at $167,000. And if we carry this on all the way up to day 31, let's see. Hundreds, that we're at $10,737,000. But that's just the amount that I get on day 31. Because each day we get to keep all of this. So what's the total sum of all of this? $18 million. You did tell me. Yep. So it is absolutely a trick question, but like you can kind of smell that something's a little fishy. You're like, yeah, this is like it's a really weird question to be like, I'm gonna give you a penny today, then double tomorrow. And I would imagine it does not feel like that's gonna happen. Because at least for me, it doesn't feel like we're gonna have $18 million by the end. I'm like, you double it every day. I don't know, it might be more than $100. But that's the power of doubling, and that's the power of exponents, because this right here, we did something called an exponential function. All we did was times 2 every day. Guys, when we do times 2 times 2 times 2 times 2 times 2 times 2 times 2, wait a minute, that's an exponent. What we did right here was we did 0.01 times 2 to the 31st power. We did times 2 31 times. Nope, we did it 30 times. We didn't do it 31 times. We only doubled it because the first day we only had it. All right. And there's that exact same number that we got here for our day 31. Using an exponent instead of having to do every single number. So, all right. So the opening activity that they have for us in the book, the way we're going to do this is you're going to open yours up and it's going to have notes and stuff. And you're going to be able to, like, you know, type the things. And then down here at the bottom, you'll be able to move on back and forth to different things. When we're all set on this one, oh, you can fill, oh wait, I'm supposed to enter numbers here. But then I'm gonna be able to go on to the different sections. And we're gonna go through this together. I don't know if we're gonna finish it today. I'm gonna see where we get. So, but you'll need a piece of paper for notes. You also need a piece of paper for this first activity. Maybe 2 pieces of paper. If you need paper, people at home, if you want to come over to my classroom, I can give you some paper. People in the room, if you need paper, I've got plenty. So feel free to grab some if you need some. If you guys miss any of this, I'm going to try to make the Zoom available after class on YouTube. So just take a few minutes now and well, here, I'll read the directions to you.
2 pieces of 8 1/2 inch by 11 inch paper. Fold one of the pieces as in style 1 below for 5 folds. Fold the other as in style 2 for 5 folds. After each fold, unfold each piece of paper and count the total number of rectangular sections. Part A. Find.
So you fold it, you fold one paper one way, you fold the other paper the other way, and you count the rectangles. That's all you do. Count the rectangles at each step. The cool thing is you can do this with any size paper and it'll work the same. So I'm going to do mine, you do yours, and then let's compare. So like as you go, you can fill out your table. So like when I put one fold into my accordion, I saw that there were 2 rectangles. If you think you know what's going to happen next, feel free to, make predictions and stuff too. And people at home, if you're participating, if you can just drop me a private message in chat to let me know that you are actually following along with us today. I'm just trying to, you don't have to say anything more than, hi or whatever. I just want to make sure that you guys are with us. Which one? So you're just gonna you just fold it once and then you open it. So you got like 1, 2, and then you'll just put another fold in it like that as you go. My challenge to you is 6 folds on the folding in half. Not the, what am I saying? The style 2, the half folds. I just did the 5th fold. I'm like, there's no way I'm able to do the 6 folds. Thank you for letting me know that you're following along at home. Now I know who I'm talking to and who to not expect to turn anything in, and I'll know why. Because it was 3 of you that replied to me. That's the discouragement that the other teachers were talking about to me. That it's no one's interacting over Zoom. This is, as teachers, we spend a lot of time getting stuff ready. Like I spent an hour getting this lesson ready for you guys today, and then to find out, that only 3 people at home are actually following along. Again, I'm not discouraged. I'm a little disappointed in my other students, but somebody who, is I'm just telling myself I'm not discouraged. What was I on here for? Oh, you were saying you were having trouble last time too. Here, let's go into a breakout room real quick and we can figure it out. Hopefully you've had a chance to go through and do the folds. Can someone share what they got for the style 1? You got a fan. Bigo, what'd you get? Oh, I thought you were sharing. Sorry. Emily, did you want to share? Sound good? I don't get anything different for that one. I would assume we got the same thing. Cheyenne, from my angle, that looks like a house. That's great. Anyone want to share what they got for the other one? The half folds? Oh, good. Thanks for letting me know that. Anyone want to share? Go for it. Oh yeah, sorry, Dennis, here. Oh, you got, okay, so 32 for the last one, and then what was happening? What was happening each time? Yeah, just like with the money thing. And that makes sense if you think about it. When you fold it in half, you're getting two pieces where there used to be one. And that's the right number for the end. So I'm not sharing my, I'm not sharing my numbers up here because I want to make sure I'm keeping everyone honest. And if someone is at home not paying attention, they're just copying my screen. Like, I don't want that to happen, but I want you to get the right answers and stuff. So if there's an issue, definitely let me know. So why do you, so part B is, oh, what's up, Emily? Oh, what'd you get? Okay. Interesting. So you were folding it a little bit differently, and that's good. Interesting. Okay. So the way that they wanted us to fold it, it was supposed to be, does that make sense about the getting 2, 4, 8 instead of what you got? It's okay if it doesn't. I want to help it make sense first before. So the way that oops, that's not a rectangle. So if we have this, the first time when we fold it, we get like half this, we get 2. And then when we fold it again, they fold it the opposite way. And then what happens is if you imagine it's folded and folded, so folded, folded, we have this piece and then we fold that in half, and that actually brings in like 2 more lines, and when we fold the other way, it brings in 2 more lines. So it winds up like taking little pieces and making it doubles the number of folds every time. I'm not sure if that helped at all. Okay, right. Okay, so go ahead and answer A and B, and write something about that. There's no like right or wrong answer here. We're exploring right now, and we're just trying to think about what's going on. So I will give you like quote unquote correct answers in a couple minutes, but I want to give you a chance just to think about, why did this happen or what's going on here. And if you're like, why haven't we done stuff like this before? We normally skip these activities because I normally think they're really stupid. I don't think this one's as stupid. I thought this one was kind of fun, so that's why we're doing it. Oh, that's good. That's not as much of an issue then. But yeah, if it happens again, let me know. I'll still let my supervisor know about it. That's something that the company's going to want to know about. Oh, Savannah, I got your email. I haven't opened it yet because I want to make sure that I don't lose it in the list of emails that I have. So I'm going to be checking that at some point soon. All right. Did anybody want to share anything about what they wrote for A or for B? I'm going to move into slide number 2. So I think what's going to happen is at the end of this, I'll be able to go through and see what each person put for each thing. So I'll be able to see what you wrote. I think that's how this works. And I think that you're going to be able to go back and see what you put for stuff too. So like with open notes, tests, and quizzes that we have, you'll be able to go back and check what you wrote. Okay. 2 to the x. I am not sure if this is a scary notation or if we've actually talked about this before. My memory is not serving me well. I want to know if is this thing f parentheses x parentheses. Have we done this?
Yes.
We
I
have.
remember that.
Okay. There's a synonym for this.
Isn't this like a function?
Yeah, this is called a function. Yep. And the synonym for this guy over here.
That's the coefficient.
Yeah. So whenever we see this f of x business over here, you can just remember it's just a fancy way to write y. So don't let it freak you out. Just remember anytime you see that, it's really just saying y equals stuff. So y equals 2 with an exponent of x. 2 with an exponent of x is weird. We've never looked at this before. So let's talk about something we have seen before. What was this the equation for? Yeah, slope. And what shape would that make when we graphed it? Yeah. And this is called a line equation, except we have to make it sound like we use proper word endings and we call it linear, right? It's linear. This is a linear function. This guy over here, what's the weird thing about this is the exponent, right? So this is called an exponent, but we don't call it an exponentier, you know, linear. We call it exponential. Yep. So it's called exponential because that's the kind of the weird focus of x. So this is called exponent. IAL, exponential. So our variable is an exponent. So our independent variable is an exponent. What would a graph, so this is actually an exponential function here. What would a graph of all these points on a timeline look like? Day 1, day 2, day 3, day 4. Dennis, what do you think?
It'd be like curved line.
Yeah, it's not gonna be straight anymore. It's gonna be a curved line. And what do we notice about the beginning versus the end of this line?
It's a lot bigger.
So a feature of exponential graphs is they tend to start small and then blow up. And if you've already clicked, which is totally fine with me, if you've already clicked on the, that's not it. Where'd you go? Where are you? Here you are. If you already click solution, you can see 2 to the x. It's like just barely moving, barely going up, and then whoosh. And if you zoom out, like, woo, it is a swoop and a half. So whoop. If you go off to the left, what? That looks like really, really tiny. That's like 0, isn't that 0? Let's see. Nope. Yeah, it's 0. So here's the thing. It may look like it's touching 0, that the y values are touching 0. The y values actually never touch 0. The reason why it looks like it's touching 0 is because it's just the computer's rounding, and it's so tiny that it rounds down to 0. Like at -10, we're already at 0.001. And so by the time we hit like -15, it's so tiny the computer can't even round it right. So it never actually hits 0. And that's one of the things that it says here. As x values approach -infinity, which is a weird way to say, but that's just saying go off to the left forever. The y value is getting closer and closer, or approaching 0. And then you can see the y-intercept, because it's right there, right? The y-intercept is 1. This is information that's worth writing down. So like if I was taking notes, I might have written this so far, and then I might draw a little like swoop like this for the, so you could say like the y-intercept is 1 or something. In a few minutes, we're actually going to learn there's a way to know just from looking at the equation what the y-intercept is. How do we know the y-intercept from like linear equations from these guys over here? How would you know what the y-intercept is just from looking at the equation? Anybody remember?
Isn't it just like, it's right there in front of you?
On this one, it's right here in front of you. Yeah. Emily? Yeah, it's just that number.
Oh, that's what I meant.
On exponential functions, it's similar. There's a way that we're going to be able to look at it and just know. The thing is, since it's 1 this time, it's not very apparent, but we're going to see in a couple of minutes. There's a way to look at an exponential function and go, oh, the y-intercept's just that number. So then the next part, there's a down at the bottom, that was page 1 of 3 for part 2. If you look at this one, you can just click solution.
What are the characteristics of the graph of f of x equals 2 to the power of x?
Sorry, that's too fun. So something important, there's a lot of information here, but I want to talk about something called this right here. I want to give you guys a chance to try to sound that out and figure out how to pronounce that. Just for fun, because like I'm going to tell you how to say it in a minute, and then you'll know. But if you've never seen this word before, I'd really love to hear you take a crack at it, just for fun. Because it looks really, really messy, doesn't it? Come on, have some fun with it. Try to say it. It's a really weird word, right? Before I tell you how to pronounce this word, we should talk about what it is. This thing, whatever it is, however you pronounce it, if you remember a minute ago, I was saying that our curve gets closer and closer and closer and closer and closer to 0, but it never actually hits it. So this thing is that place that it never actually hits. So that's what this thing is. So I am now going to help you pronounce this. The P kind of falls off, but this is how you pronounce it. I'm sorry for the bad language, but it helps you pronounce it. Asymptote. So what I usually say is I usually say asymptote. asymptote. Most people don't actually pronounce the P. So let's delete that word. Okay. So that's it. It's asymptote. That's how you pronounce it. And you emphasize the bad word at the beginning. So too late. So yeah, no. And the main idea of an asymptote is you're getting closer and closer and closer and closer and closer and closer and closer, but you're never actually touching it. So the function gets closer and closer to the x-axis, but never quite reaches it. When a function approaches a line in this manner, the line is called an asymptote. Yeah, okay. I guess that was a little bit of a Kermit voice. The asymptote of f is y equals 0. No, okay, so whatever that line is, we say y equals whatever that line is. And a lot of times for us, it's going to be 0. So we could say our asymptote here . Oh, wait, that's not what I meant to write. So whatever it levels off to, we'll say like y equals 0. All right. And then there's a page 3. Oh, okay. So now we're going to start thinking about what does this number do? This number to the x. So if you've never messed around in Desmos before, what you can do is you can go in here and you can write y equals, and then you can do 2 to the x, and you can use like you can use the little keyboard that shows up here or however you want to do it. But look at those two and see how they compare. And we're gonna learn something about what that number does. By the way, I'm not expecting you guys to write anything in this box. I wrote okay so that it would like let me click check answer. But so how would you describe these two pictures? What would you say about them? The two different graphs that we just got. Like, don't worry about what the book says. Like, what would you say about it? Oh yeah, yeah. Where are they intersecting?
Like in the middle? Maybe
Yeah.
like one?
Yeah, they're intersecting at their y-intercept actually. Yeah, right there in the middle. So they have, that's interesting. They have the same y-intercept. So that number, the number that's to the x, that doesn't actually change our y-intercept. That means there's another number somehow that we're going to be able to change that's going to be able to affect the y-intercept. How could we contrast these two pictures? What would we say is different about them? I'm trying to get you to say kind of obvious things just so that people are saying stuff out loud. So maybe it's not obvious. Maybe I think it's obvious.
They're mirrored.
Oh, that's a good word.
Flipped.
Yeah. Flipped, mirrored. Anyone know the fancy like mathy sounding word for mirrored, which I'm fine with mirrored and flipped. Those are what I normally say. Ooh, that is not even what that's even better than what I was going to use. Yeah, reflected. Ooh. Yeah, the math word I was thinking was that they're symmetric to each other. Like they're But yeah, mirrored, reflected, flipped. So yeah, they're symmetric about this y-axis here. Great. Oh yeah, somebody said that in chat too. Great job, everybody. Okay. So there's actually a connection here. And I think we get to, we're going to talk more about this connection in a little bit. I don't think we're going to talk about it right now. I want to get through a couple more things before lunch. You guys are doing a great job keeping up with me. I think we're going to do, yeah, okay, here we go. So we're going to go to the graph on this one. And the y-intercept, I think, is going to be very clear now. Oh, no. No, I didn't want that. I wanted to be able to look at it in Desmos. Dang it. Here, you can not look at Savas for a minute if you want and just look at my screen. I'm gonna share something in Desmos. Where is it? Where is it? Yeah, there we go. Okay, so I'm gonna have y is equal to 2 to the x. Okay, we got the 2 to the x that we were looking at. Check this out. I'm going to type the number 5 here and see if you can see how the number 5 affects the graph. If you're looking anywhere but my screen, I'm not talking to you because I don't know how to talk to you if you're not looking at my screen right now. But, huh. Okay. I'm going to type another number there. That was 5. I'm going to type the number -3. But now I'm going to type the number 2. But anyone have any ideas about what this number does? Here. So here's our y equals 2 to the x. I'm going to type the number 7. But now I'm going to put the number 1 in there. Is it too obvious? Is that why no one's saying anything, or is it not obvious?
Where they cross the y-intercept.
Boom. Thank you for saying it out loud. Guys, that number in front of it. Wait, but there was, for a long time, there wasn't any number in front of it, and our y-intercept was just 1 every time. And like, yeah, I put it in there and it made 1, but like, why does that still have a y-intercept of 1 if there isn't a number there? Emily? Yeah, exactly. Yeah, it's just because it's just an imaginary 1 times it. So if we go back to the examples in our book, like whatever that front number is, that is always the y-intercept. And I know that there was that one that was upside down. Negatives will flip things upside down. Oh, sometimes you'll see it like this too, where like it'll be the number times something to the x. But so like for this one, my y-intercept is 4. And then we're gonna move on to the next piece, I think. Yeah, that's the only thing on that page. Oh, Emily, what's up? Say it again. Oh, yeah. Ooh, I'm getting a phone call. Hello. All right. I thought it was gonna be a robot, but it was a real person. And they're calling me about a doctor's thing. I was like, ah, man, I don't get to give you a hard time. Okay. So this is one way that they talk about it. I think this is a snippet straight out of our book. I want to add a couple of things to this. And I want to encourage you that as a student, copying word for word from a book, for me, does nothing. I learn nothing when I copy word for word. I want to discourage you from copying word for word because that's usually not how people learn. That would be like saying a photocopier learns things when we put a piece of paper on, we click copy. It's not learning anything, it's just spitting out what it sees. What we need to do is we need to take the information and turn it into information that's helpful to us. So let's see, an exponential function is the product of an initial amount. Wait, but we said this initial amount, this front number, we also said this was our y-intercept. Initial amount, is that a phrase that makes sense to you, or is that a weird sound? Like, anyone not sure what that means? Or maybe can somebody rephrase initial amount? How would you explain initial amount to a 5-year-old? Perfect, yeah. Oh, wait, online if you missed it, original value. Anyone got a different way to think about initial amount? Okay. B is the constant ratio. What that means is that's the number you get multiplied by each and every time. So like when we saw 2 to the x, we were doing times 2 times 2 times 2 times 2 times 2 times 2 times 2. So whatever that is. When B is greater than 1. When B is less than 1. We got to talk about this. So when B was 2, we swoop up. The bigger B is, the steeper the swoop. But if B is less than 1, and like, I mean a fraction, I mean like a number less than 1, but still greater than 0. So like if B was, what's the number between 0 and 1? Anything you want. Fine, I'll pick one. Whenever it's a number between 0 and 1, it does that mirrored reflected thing that we talked about. So I might take a little note and say when B is greater than 1, and I draw the regular swoop. And then when B is less than 1, I might draw a reverse swoop. For me, that's a helpful reminder. You might need to write something different. So I was talking to Mr. Marianello about like, what do we need in Algebra 2? And he was like, some of the important ideas that they really should come out of Algebra 1 with is that they need to know how to figure out which way the swoop goes. He didn't call it a swoop. I'm calling it a swoop. You know what the A up front does, that the A is your y-intercept. So all right. Keep going. Was that it for this? Then we're on to 5. Let's see, what does 5 ask us to do? Interesting. Is that this? Okay, cool. So this is the last thing we're gonna do before lunch. We're gonna look at these. So I'll read the question out. A network, wait, no.
A network administrator uses the function f of x equals 5 to the power of x to model the number of computers a virus spreads to after x hours. If there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network?
So if we make a table out of this, all we're doing is we're plugging in different values of x. Super easy to do in your calculator. You can click 5 to the 0, you get 1. 5 to the 1, you get 5. 5 to the 2, 5 to the, this button right here where my mouse is hovering right now, that's the exponent button. Don't click it this many times, it won't work. But 5 to the 3. And that's where they're getting their numbers here. So how many hours does it take to get to 1,000 computers? So it should be painfully obvious because the numbers are right here. At 4 hours, we're at 625. At 5 hours, we're at 3,125. So somewhere between 4 and 5 hours. So, oh, okay, they go and graph it. That's cool. So between 4 and 5 hours, they say 4.3, good for you. Oh, wow, we can even use it. Right, yeah, okay, yeah. So one way to do this is like, okay, there's 5.4. Well, what about 5 to the 4.1? Not quite there. 5 to the 4.2. Not quite there. 5 to the 4.3. Aha, there we go. And you could even be like, oh, well, maybe it's between 4.2 and 4.3. Be like 5 to the 4.25. Ooh, not quite that. You can keep getting more and more decimals if you want. You don't need to. Eventually, we're going to learn, I think in pre-calculus, you learn a special technique to find out the exact exponent that you need, but that's not for this year. So it'll take the virus about 4.3 hours to spread to the entire network. So before we go to lunch, try to find for 50,000 computers, same thing. And people at home, we are gonna, you know what, people at home, we're gonna stop. That's the end of the day today. Next time we're gonna come back and do more. So we're gonna end there. So after lunch, if you want to come back, you can, and we'll talk about other things. But that's the end of the lesson for the day. Otherwise, just make up stuff if you're missing stuff and turn things in. So go for it. You can turn that part in, and then you should be able to pick up where you left off next time. Yeah, me too. And I'm actually going to end the Zoom right now. I will start the Zoom back up after lunch, just in case you're coming back to get help with anything, but so that I can upload this to YouTube. So have a good one, everybody.